Alessandra. I'm currently working as a data scientist at Capital One Canada. Before that, I did my master's in biostatistics at Queen's. And before even that, I did my undergrad at Waterloo in statistics and health informatics.
So I'm Kanika. I'm currently working as a data analyst with Wish. I'm in my 4th year of math, finance, and stats at the University of Waterloo.
I'm Niaz. I'm a 4th year student. I'm studying math and business, Waterloo and Laurier, and currently I'm a CGI intern. I work at CGI. I'm a machine learning intern. Before I was at Script as data science intern, and before I was at Scotiabank for business intelligence.
My name is Veronica. I'm currently a master's student at systems engineering at Cornell University. I did my undergrad at Ryerson. I double majored in math and computer science. Currently, I'm at Scotiabank as a pricing data scientist intern, and I was previously at Chopra.
In my current job at Capital One, I'm embedded in a business team. So what that means is we have a team of data scientists, but we're working within a larger section of the business. And we work basically side by side with the business analysts, and we have process managers and the leadership team and things like that. So there's a lot more meetings than what I imagine a typical data science role would have. But we start our day with stand-up, pretty standard stuff about getting updates from each other and checking in on progress for projects. Throughout the day, we typically have some project updates. So that is reserved for people working on the same project to get a little more face time and actually collaborate on the work. And then I probably have about 3 to 4 hours of time just to work on my own. So that would be coding away or creating presentations to share out with stakeholders. Being part of the business side of things, we actually have a lot more presentations and a lot more PowerPoint slides to make than I ever would have anticipated.
Like I said, I'm working as a data analyst with Wish. So my time's kind of split between either building up pipelines or doing some modeling tasks. Typically for building pipelines, it involves actually getting the queries that you need, constructing the pipeline, testing it, and then validating the data. So it kind of depends where in that process you are. Usually if I'm running a pipeline, I'll let it run overnight so things are faster, and then I'll validate the data in the morning and then do the rest of my tasks throughout the day. For modeling projects, it really depends where in the stage you're at. For some of the projects I'm working on, it's building models from scratch. So I'm currently in like the exploratory stage. So after I deal with like the data validation for my pipelines, my day will continue with me looking into doing like deep dive investigations, trying to do some research in the types of models I could be using, and then kind of playing around with the data. So like your tasks kind of really vary on like where you're at with the project and what kind of work you're doing. But that's kind of the typical day that I've had so far for my internship.
At CGI, it's a little bit different. So I'm just going to say what I'm currently doing is more like ML engineer, so like machine learning, ML ops. So for example, my project right now is to recreate the ideal data science kind of environment. So you would usually, I think what's commonplace is people do Jupyter Notebook or any kind of other Python notebook, and that's where they do their data prep and modeling. So what we're trying to create is to have, for example, Jupyter Hub. So you would have it on the cloud so you can connect with different teammates. You would have Kubernetes for container management, so you can keep like the environment the same for other people to do testing or version control. And you could have something like Elasticsearch that would have all the data from different parts of the organization kind of stored there so you can query this. So essentially, what would a very like integrated, seamless data science environment look like? So that's what I'm trying to do. I think what would probably be more applicable for this question would be what I was doing at Script as a machine learning intern or data science intern. So what I was doing there was first I was doing 2 unsupervised algorithms. So one was dimensionality reduction, the other one was clustering. So it was kind of reading different research papers about the implementation, about the algorithms, and then looking into different implementations, see what suits us best in terms of like efficiency or performance or any kind of metric that you're looking for. And then after, because it was unsupervised, I had to create kind of a performance metric to see how well the project is doing. So I think that would probably be more of a typical kind of a machine learning day-to-day job.
Currently, I work on the pricing team. So for example, if you were to go get a loan at Scotiabank, right, they give you that percent. We're the team who decides what the percent is and all that. And I didn't have any background in finance. Like I started university in financial mathematics and then switched to a double major in math and CS. But like, I mean, those first year courses don't even count. Like I come in basically not knowing anything about finance. And I'm like, cool, I don't know what's going on. I don't understand why this loan is normal and why this isn't normal, but here we are. So there was definitely a bit of a learning curve on that aspect where like, I understand the models they've used or like why they're trying to phase out certain models because they're not as accurate and there's better methods. But like the context in terms of like seeing the data and then being like, this is what it's supposed to look like, that's a bit of a challenge because I don't have that same type of expertise that the rest of my team has. And a lot of them are like they've been in banks for like 8 years plus, and then there's me. So it's a bit of, a disproportion in terms of what is kind of expected for you to know. But my team, at least, like, we talk a lot. So we have a lot of like daily short meetings to kind of like brief other people on the team of like, what am I currently seeing, to make sure that like they can help catch things in each other's work. So a lot of times we happen to work on like long-term investment prices. So in those cases, we try to kind of like compete against each other's models, or like we have existing models that we try to then have like competing adjustments to, and see whose performs better based on different simulations we run on them in long-term performance. So I think that like having that little bit of competition in between the team, between everyone, is fun, since it kind of spices things up, and it's a great way to learn off of each other, which is definitely like a big part of the job, is just, reading the papers, finding out from other people what's worked in the past, what hasn't, why are we doing this approach, and kind of like iteratively developing a better model.
Really the focus is on like study design and making sure that you're collecting the best data you can in the right way, so that you don't waste all this time and money and then really not be able to get any actionable insights out of it. And so in statistics, there's not really like side projects you can do. You can't just like go ask people for their data. They don't like that. But I'm also not particularly technical. I took the minimum number of computer science courses that Waterloo required of me. And really the rest, I kind of just had to learn myself on the job. And I've really found that I'm not the only person with that experience, at least at the places I've worked, because it is such a new industry. There's not really rules for what you have to be able to get into it. So really my focus, and I think the focus in our recruiting efforts also at Capital One, is really on problem solving ability, really thinking through the problem and understanding like where the challenges are going to come and what you need to do to overcome them. Whether you can actually do that yourself or not is a different story, but just those critical thinking skills are really like the hallmark of what I think makes a good data scientist. And like I had mentioned previously, in my current role, there's a lot of discussion with non-technical audiences. So communication skills, which I guess falls a little bit more into soft skills. I think it's important in all workplaces, but I think it's especially important in an industry like data science, where it is so new, and so people have potentially no expectations and no knowledge of it. So to really come across strongly, yeah, it's all about your word choice and understanding which audience you're talking to.
For technical skills, I would say Python and SQL are a must. That's basically like how most companies will interview you with some coding challenge or assess your technical capabilities on the spot. Sounds a little bit scary, but usually if you do enough practice, there's a lot of resources online, and that's not too difficult to learn. If you're starting with like one of them, I would say start with SQL. Personally, find it easier, and it makes like a lot more intuitive sense. So that's like, those are two tools that are like most companies use, and it's always in like a data science like toolkit. I definitely agree with the soft skills. You need to learn how to communicate your results to either technical or non-technical audiences, especially when you're dealing with like a virtual internship. You need to be able to communicate your results and like the work you're doing to your coworkers. If you get up into like higher up roles, I've seen like my managers having to convince like higher up directors or executives to be able to like pitch like a data science project, and you need to show them the business value. So if you don't understand like the actual business impact, and you're not able to like take the data like in the idea you have and then communicate those results to them, you won't be able to sell the project, and you might not get approval. So it's definitely something that's really important. In terms of like side projects, I think a lot of people say you need to do a side project. I would say only do it if you're actually really interested in like something you're like, or like you see a solution to something you're interested about. I went down the route of being like, oh, I need a side project before I go into data science. Like I need this to put this on my resume so that I get considered. I half-assed a side project, never finished it. Honestly, didn't learn too much from it, except like some familiarity with some like of the Python tools. But overall, I would say it was a waste of my time to try to cram a side project in right before interview season. So if you find something you're actually interested in, or if you find a couple of friends to work on something, like do it then. But I wouldn't do it just for the sake of putting it on your resume, because when you talk about it, it kind of shows if you're not too passionate about the idea. So I'd say like get familiar with your technical skills, be able to like actually communicate and problem solve, and then see if you find something you want to do a side project on, or go to a hackathon and do one on the weekend.
I did a side project that I really was interested in. And I could talk about it for like so long. So I scraped Reddit. I was trying to see how a Reddit post would go viral. So I kind of did that, and I was really interested in it, and I think it was fun, and I think it did help me in the long run a lot. One thing that I think you should absolutely do for a data science side project is please don't just take a data set and run with it. Gathering your data, especially if it's unstructured and it's like ugly and gross, that's the best kind of like start point. Because to show that you know how to prepare and clean data, and to That's like such a huge part of data science, is to, you know, there's so much that goes into cleaning it when you get the data set. So being able to showcase that you know all those things, like, you know, that you have to encode categorical variables, and like then you do label encode, or what how to encode it. It's like that you understand just like those things that you probably would have to do on your day-to-day job. I think is so valuable. So if you are doing a side project, like I said, don't just do it because you have to. Do something that shows your value in that way. Unfortunately, there's two types of coding challenges you get for data science. One is an actual data science challenge. So if you're going to interview, it's usually, from what I've seen, the first part's like Python and the second part's like SQL. So you're going to have to use both. The other one is like software engineering. And it's so annoying because it's completely useless and it's like they don't understand what they're asking for. And so unfortunately, sometimes you might also have to do like something like lead code just to get through the coding challenge. That's just a useless way to go about it. But on the same theme of people not understanding it, like Alessandra said, I think, so the problem that I've seen in my experience is that people don't really know a lot of times what they want. So they'll post a job and it's like, you want a data scientist, but you look at the description and the requirements and the tools they're asking for, and what they're really saying is, I want a software engineering that maybe knows some machine learning. So you really have to kind of learn to read between the lines and see like what kind of jobs apply to you. And so I can't really say that this is what you need to be working on, because there's so many roles within like the data world. You can be a data analyst, business intelligence, machine learning, data science, machine learning engineer. Like they all have completely separate kind of toolboxes you have to kind of be working on. And I can, like, if you ask me separate ones, I can try like give you my best shot at what I think would cover it. I think for sure Python and SQL, like any variation of SQL is important, because you always have to kind of query data or like clean it or prepare it in some way. But for example, business intelligence, you might want to do something like Power BI or Tableau. For kind of like the engineering, machine learning engineer side, you probably want something for like containerization. So you would maybe want Docker or like Kubeflow or something like that, or like Kubernetes. So it does depend on the role. I think the best way to go about it is to just go through like 100 different postings, see what they have in common, see what kind of like role they fall into, and that will really give you an idea of what the current state of the industry is, because it does change very rapidly. So I think that's probably a good starting point.
I've used Kaggle in the past before I got my research job to just kind of figure out, like, you know, what's Python, the common libraries I've been hearing about, and those types of things. There are some very disgusting data sets that you can get on Kaggle. So trust me, if you want to practice data cleaning, you don't have to search that far. They're there. They're horrendous, and you're going to hate yourself. But trust me, it's a very good challenge. Like when I was previously at Shopify, I did NLP there, and I was looking at messages that happened to be like being sent over Shopify's platform. That's how we had them. And boy, let me tell you, when I saw those messages, I was like, you guys are joking. Like, who are the data engineers who allowed this to happen? Like, who allowed this? And then you're telling me that I have to clean this? Horrendous. I spent more time cleaning that data than doing anything else, because it was that bad. And the worst part is that sometimes, depending obviously on what you're working on, but when it comes to, for example, like the servers that emails are sent over, some of them have different formats that are like embedded in them, and then you see the disgusting HTML like garbage spread out throughout the email. Man, it is so hard to cleanly filter for that stuff, because everyone has different sets of characters. You don't know if you're taking out a punctuation. You take out too many punctuations, your sentence doesn't make sense anymore, and then all of your like analysis and buckets afterwards, totally wrong. You have your sentiments gone. And I'm just like, why? Why is this my life? But that's actually a huge part of data science, because I talked to other people, at least at Shopify, and like that problem is huge, especially if you work in a company that's like growing rapidly and they haven't had like a lot of time to build like good long-standing infrastructure. Man, you're in for a world of pain. But by doing those types of things, it doesn't have to be anything crazy. Like the fact that you can show the employer that you can do these like very important base skill set things is enough, because the later things you can build on. Like I've talked to people who've had data science like in other, we'll say, larger companies like Google and similar, and in some cases they've gone over a year and they didn't use any machine learning, like none. It was just simple like regressions or stuff like that. So you don't also have to do anything like crazy to stand out to an employer. Like they really just want to see, like, is this person a competent data scientist? Like that's it. The fancy things you'll learn on the job, whatever it is. And if you get lucky enough, then I mean, they'll let you do some fancy machine learning and whatever, but that's just like a bonus.
Really, it's been interesting in like the consumer banking space, because really the way to distinguish ourselves as like a smaller company is about figuring out really what's missing from the market and like what we can do better than the big banks can. Because when you have that many products to carry, there's no way that like they can all get the same sort of time and attention from the team that that they necessarily need. And we've kind of seen that in market trends where we've had a couple of really good products that like definitely hit like a gap in what the big five banks are doing because they really only focus on each other.
Picture any e-commerce site to like drive your personalized recommendations, your pages. They use all of like your past history, items you've clicked on, items you've viewed, promotions you've looked at. They kind of have like all your data on that. So they kind of use that to provide you with like discounts or special prices. If you're inactive and you're becoming a churned user, so you're not on the site as much, they will send you more discounts. Maybe they'll give you like more promotions. So like that's like one way data is heavily used to improve the experience for customers, and they make it easier for you by being like, oh, you like a lot of like, let's say video games. Here are some of our video game discounts, or like here's like some other vendors that are also selling video games. So that's really useful. Another way that's used is like fraud detection. So both on like the consumer or merchant end, you don't want consumers who are being like, oh, I didn't receive my product, but they actually received it and they just wanted the refund and then they mail back like an empty package. So that's one of the main issues. For merchants, I think especially with Wish, since we have a lot of like international merchants, there's an issue with like, did my product never arrive because it got lost in the mail, or did the merchant just never send the product out? And so we also look for a lot of fraudulent activity within the app. So all of that's really dependent on data. And like there's a lot of data available on both like the consumer and the merchant side. And I think like without data science, we wouldn't be able to have like these really personalized recommendations or be able to do a lot of the decisions that we have. So like the like use cases are constantly being like adapted and growing. I think it's like a really important like concept and like part of like the e-commerce industry.
In IT, you can imagine we do a lot with data. We have a lot of there's a lot of companies that will come to you and maybe they've never had a data science team and they're want to know how to start their tech stack, or what kind of projects that they could do, or what kind of data they could be collecting. And it's really cool to be in consulting because you get exposed to a lot of different types of industries. So I think all of them are kind of like slowly waking up, even like the really old ones that have still everything like maybe printed and they don't even have like databases to collect their data. So I don't really have a specific example I can tell you, but there's definitely there's an insane amount of applications. And I think currently it might also be just a bias that I have, because obviously if you're a big tech company and you data science or machine learning is like the central to your value, you're not going to come to probably an IT consulting firm. That's probably you want to maybe you will, I don't know, I haven't seen all the clients obviously, but I think that from what I've seen, it's been mostly kind of companies just trying to just understanding the value of data science and machine learning and just trying to see, okay, this is what I have, what can you do with it? Like, can you save me any money? Can you maybe improve our competitive advantage in some way? So that's mostly been what I've seen in my experience at CGI.
Banks finally woke up and were like, maybe we can use some data science stuff and actually, get something meaningful out of this. And the VP actually of my team, he used to work for, I believe, PC Financial, just when PC Financial was starting out. And he even told us then that the changes in data and what data brought to PC Financial as they were starting, and kind of him being there, really saw the evolution of how much data can really help drive a business and help them grow a lot faster than if they didn't look towards this. And at least at Scotia, they're really seeing the value that it does pay to actually have people sitting on these algorithms and working at them all the time and trying to maximize what can we give the customers and still make money for the bank. So that's definitely a growing field, and they seem to be looking for a lot of people who are very specific experience in this field, understanding finance, understanding why these products work the way they do, since that's such an important part of understanding, how can we approach these problems, since they're very industry specific. And also being able to kind of forecast, how are we supposed to play out these things, especially during times like COVID, that very much changed how they approach things, especially when the Bank of Canada cut interest rates. That was kind of a panic zone, and everyone had to kind of scramble to be okay, so what are we doing? Do we have promotions? What's going on here? What targets are not being hit? And being a good data scientist, especially in these times where you don't have a year ago's data to look at that reflects today's situation well, you're kind of in the dark the whole time, and being able to still produce something that the higher ups aren't going to be you lied to us. Why is this not what you said it was going to be 2 months ago? So it's kind of scary. But we have that kind of responsibility where we're showing more and more people that we do bring value to the table, and that there's a lot to be explored that the bank has never looked at before, and that value is there. It's just that someone needs to be working on this all the time and really get to know the area.
Coming in not really with a CS background or computer science, I think that the thing I find the most difficult is really staying up to date on the new technologies and all of the new methodologies that are going on, particularly with like, I guess, all the cloud services that we're now looking to move the company processes onto, and tools to interact with those new servers and new systems. And so at my job, at least, there are like a whole team of people who don't have models that they own, unlike myself. And so their job is to like make the workflows happen so that everyone else in the business can use them, and particularly even make them simple enough so that the business analysts can use them who have no data science training. And so really, I find that even though I struggle with that and I struggle to constantly adopt like everything that's changed, it's really rewarding to always have somebody to learn from, always know that there's something new that I can learn today. And really, I try to make that my focus, because it's one thing to just like churn out results and produce what someone might think is valuable. But if you're not growing, or if you don't think that you're really gaining anything from the experience, it's not a job that like you'll be able to stay at for very long if you don't find value in it for yourself. So definitely the new technology, constantly getting to learn, but it is a challenge to keep up with.
One of my biggest learning curves was getting familiar with Airflow for building pipelines, and then also figuring out how to optimize that. So like sometimes you'll get a pipeline where, like, for example, one of mine took like 20 hours to run, and you really need that to run like in the first half of the day because you have a bunch of dependent pipelines on it afterwards. So figuring out different ways to optimize it, testing those, sometimes testing it takes an entire day. So it's a really like tedious process. I found that to be pretty challenging, but it's also really rewarding. Like for my 20-hour pipeline, we got it down to 8 hours, and like figuring out how to actually parallelize data and like find different ways to speed it up. It's really rewarding to see the end of that. I think the other part that's really challenging is when you're working with models and you're trying to build something from scratch and you just have an idea, it's really open-ended. So trying to figure out where you should actually start or what part of the data you should use, especially if you have a lot of data in different tables, it can be overwhelming, and trying to get like a start on it is kind of difficult. But like once you start getting familiar with the data and you've made some progress, I can't say like for my project that I'm super rewarding since I'm not done the model yet, but I can imagine once I get there, because this process has already been like difficult enough, that like it'll be rewarding to see like some type of end product, whether it's like completely finished or not. But like working with data and like reaching like the end result or like some like product after you've spent like hours or days working on it, it's really rewarding and it's really satisfying.
I like that it's a kind of job where I don't really have the same day. I know I don't have repetitive tasks. It's nice to always be working on something new and exciting, even if that's something new and exciting, something that you've never done before. So you have to learn it, and it can be kind of intimidating sometimes. And that's also a challenge of it, is that I never feel like I'm done. It's like you can never rest. Like Kanika's mentioning Airflow, I'm like, oh my God, I don't know what that is. Like, I've never used it. Like, should I have that on my resume? And it's like, you're constantly trying to see, okay, am I behind? What's going on? And like, what else of the 112 things that's currently like they're expecting to know am I supposed to be learning right now? But it's just nice to, I think if you have the mental energy to constantly just like, be doing new stuff and, you're always learning, I think that's good.
I think it's sometimes implementing models and having the results come out the way they should, but they don't. And depending on what paper you read, sometimes the authors like to be very vague about certain steps, and they're just like, okay, you import this and blah, 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 and then boom, you have your answer. And I'm like, what happened? Where did it come from? I don't have my answer. My whole thing is broken and I have 50 Python errors here. Like, what's going on, guys? And sometimes it's just like, it gets really frustrating, especially if you're working on like a complex data set. Things should be going correctly and they're not, and you have to kind of struggle it like the way you're by yourself through it. When I did work related to like academia, I would sometimes have to like beg authors to talk to me, which they're very uninclined to, because they're like, I don't know you, why would I help you? And so you have to be very persuasive in your emails and like, try to kiss up to them and be like, hello, esteemed professor at this university, I am so amazed by your work. Please give me the generosity of your time to explain this sentence in your paper, because I don't know what the hell I'm doing. And so some of them have been very kind and got back to me. Majority have just ghosted me. So, you just learn to live with that. But it's kind of one of those things where like, regardless of whether they reply to me or not, if I eventually get it working, whether it's through their methodologies or through just finding a workaround, I feel like that's something that you get kind of stuck in your brain afterwards, and you remember that the next time you deal with that problem a lot easier, because you actually went through that struggle. It wasn't just like, okay, I'm following some like, towards data science like article or something like that, and you just copy and paste stuff. So I think that it's a good challenge in that sense, that like you're forced to keep using those kinds of like thinking and problem solving skills that like a lot of courses have taught us. So once you leave school, you don't just totally, wipe that out of your brain. And I mean, it's always nice to be able to kind of like try to implement something new, even if it's the same problem, and see like, are the results actually going to, turn out better, or maybe I should have gone with the initial approach.
There's definitely inequality in the field. I think we all already know that. Capital One really has it at the forefront of their minds, and I feel confident in the fact that like the place I work like has recognized it and is doing what they can. But at the same time, like they're benchmarking against the current industry. So basically, like when they talk about like what proportion of women we have on our technical teams, whether that's software engineering or data science, they're always like almost proud to report that they have higher percentages of women than the available job market. But when the available job market is only at like 17% women, or like, so those are people actively seeking employment, like our 20% women doesn't really feel very good. My team actually is a team of 12, and our manager is a woman, or team lead, whatever you want to call it. But of the other 11 people, it's just me and 10 men. And even though I'm not the most junior person on the team anymore, after being there about maybe a year and a half, I definitely still feel like there's always the need for me to prove myself and to prove that I know what's going on, and that the opinions that I have to bring are just as valid. And I think it's just something that not just I struggle with, but a lot of people struggle with. And so I think that the best advice I can give to everyone, but particularly to men who are seeing this inequality and seeing like, how do I make sure that the women on my team are not feeling this way, even if you think they have no reason to be, is really to force silence into your conversation. So if you're the one leading a meeting and everyone's kind of looking to you and giving you advice or feedback on your project, really take the time to pause and soak in their information. And that really provides the space for people who potentially don't feel like yelling over others to have a chance to input. It's particularly hard on Zoom when multiple people start talking and then Zoom is forced to choose whose voice gets to be heard. But yeah, I think that's the best way that I found. And it actually benefits like introverted people, whether they're men or women, because they might not feel the confidence to like interject and say, hey, actually, you're wrong. But it gives them the time and the space to bring up their own opinions when they want to.
It's like really important, especially like if you are leading a discussion, to create an environment where you feel like your female coworkers can speak, or making sure that they're not being interrupted or dismissed when they're speaking. I've done like 2 remote internships, and it is extremely difficult to talk over like the 3 men that are dominating conversations. And I found myself usually writing down what I want to say and then messaging someone afterwards if I am not able to get my like 2 cents in, and that's extremely frustrating. But like from my experiences, it is like, I think the majority of my team, like in a couple, and like some of my stand-ups, I'll see like maybe like 3 women, and I'm like, yay, there's some friendly faces here. But for the majority of my time, like my entire team is comprised of men. And I'm actually lucky with my company now. I feel like I'm getting like a lot of support. So it's like really good that like if you are in a management position, or even if you are a coworker and you see like someone new on the team, help them out, help them get familiar. Like mentorship or even sponsoring like a female coworker that you think has a lot of potential can go a long way. Help them get like the ropes and actually progress and like stand up for them or stick your neck out for them. And like that can be really helpful. Usually like you might come into the company and have no one standing up for you, or you might not feel like your voice is getting heard. So to have like even one person on your side is really helpful. But I think like you need to be actively supporting, not just like being like, oh, we reached this quota, we're good with like the amount of women we have in our team. But there's a lot more to do within like actual company, like within your actual company, with meetings and conversations you're having, and like actually demonstrating it with your actions.
If I ask for help, which can be kind of like make yourself vulnerable, especially because when you're like a woman, you constantly like, you might question like your place in the industry or in the team or whatever. So to ask for help can be, a huge movement. People, like I got a lot of like offers, people were always trying to help me. And one thing that like my coworkers do that helps me a lot is they say, okay, Niaz, can we hear from you? Like we want to hear what you want to have to say. And even like as an intern, it's good to be valued in that way. To know that people are looking for your insights. I think one thing that I can say, this is like huge for everyone, like I think regardless of gender, is imposter syndrome, for feeling that everyone else is so amazing and so great and you're the only person who doesn't know anything. And genuinely with experience, you realize that everyone's kind of like making it up as they go, like you. For the longest time I was like, oh, I can't code, even though I've literally code like for like school and job, like projects, everything, but I'm like, oh, I actually can't code. But then I saw my colleagues and my boss code in front of me, like the live, not the end product, and I was like, this is what I do, like I do that. And it's like, people are like, a lot of like my male colleagues will be so confident, you're like, oh my god, like they know everything. But then the more you go and you're like, wait, I actually know what they're talking about and they're wrong. And it's like they just have that confidence to just say it out loud and not mind being corrected. But if I have to say something, I'm constantly like, it has to be absolutely correct, I'm not saying it. So I think those are just kind of some differences I've seen, and it's good to always, bring in the voices of your colleagues, even like Alessandra mentioned, just like the shy ones, the introvert ones, it's everyone has a unique perspective, and it's good for a team to kind of utilize everyone in that way.
So I found that in academia, like, you just have to push your foot down and you just have to push people out of the way and be like, no, this is my time. I'm going to talk about what I think is right. You are wrong, and that's it. And like, at least in academia, I find it's a lot more of like, you have to force your way into circles, because that's just how it is. It's kind of like, a bit of a rough time, and it sucks. It's like that, because I might have the personality where like, I'm okay with doing that, but a lot of people who are maybe more shy, or no, they don't feel that confident kind of, going and putting themselves out there like that and being vulnerable, that's not like what it should be like. And I think that at least on the academic side of data science, there's a lot more that should be done in terms of making that a much more welcoming, open, and also well-represented field, because it's really not. And I think that that's one of the worst parts of it, is that like, when I look for a lot of, we'll say like transportation profs that have been doing a lot of great work in data science, in one hand, I can count how many I know who are like very prominent and well-known. The rest are all men. Majority of the grad students, also men. And it's just like, you don't always feel like you're that much part of the community, because you don't feel that there's that many other people out there who are also trying to do the same thing as you. And you're like, is this like me that like doesn't fit, or like, what's going on here? But I'm glad, at least in terms of the industry side of things, I've been lucky enough that at least there's been a decent representation. I hope there's more, but it is what it is.
The Intro to Statistical Learning is really a textbook that can be accessed for absolutely anybody. It's like ground zero for stats, and it actually gets you a pretty good baseline for everything that machine learning is built on.
So if you're trying to like start off in the field, it's best to actually like try to work with the data set, look up a few tutorials and like try them out. So like towards data science is pretty good for some tutorials, or even just like following someone's notebook from a Kaggle competition and trying to learn and like tweak it yourself. Personally, I think hands-on experience is really useful, and you figure out like how to overcome the challenges that you face when you're setting it up as well.
Depending on who you're reaching out to, if they're not, I feel like, someone who might be also interning, or someone on a similar like level as you, but you're trying to, reach out to someone more senior and kind of, ask for like, would you be willing to give me some like mentorship type advice or something like this, to kind of understand like, what could I expect my career to evolve into, right? Like, how could I prepare myself for future, challenges in the role? That's kind of difficult, and I feel like women in general have been way more inclined to respond to me than men. And it's just that, like, I don't know, I feel sometimes hesitant reaching out to them, just because it's like, is it really worth my time writing you a message if you're not going to respond to me? Like, why would I bother? So I mean, that's just me though, so I mean, everyone can have very different experiences, but that's what I've seen, at least.
It's called Rewriting the Code. I think it's a really great resource. It's originally called, I think, Women Rewriting the Code. So it's an all-female organization. It gives like a lot of tech resources, tech opportunities. I 100% recommend that you guys look into it, and I think it'll be very useful to you, especially when it comes to networking, because they do have like alumni that you can chat with. In terms of actually like reaching out to people on LinkedIn, I love data, so of course, when I was doing that, I collected data, and I don't remember the exact number. It's on my LinkedIn somewhere, but I think 10% responded, or maybe 20%. 20% is very optimistic. Maybe like, I think 10 sounds about right. So you could definitely, that's one way to like go about it. I think if you are going to do it, make sure you start with like a common ground, and make sure you have your purpose there. Don't just be like, hey, let's chat. Let's say, I want to talk about this. Like, are you free for like whatever time? I think just make it clear, concise, and build common ground in that way. If you're going to do it with strangers. Me personally, I really like the same with Alessandra. All of my bosses have been men, but to be honest, I had like when you're doing like one-on-one, they've been such great mentors, and they've been so incredibly knowledgeable. And I think you definitely should take advantage of absolutely everyone that you have, especially if you're an intern, because they do see themselves in you, in that, oh, you're like, younger, and like they want to kind of give back. So I think if you're an intern, definitely take advantage of that and talk to anyone that you can, and they will be probably more responsive to this within your organization. So I didn't really see a gender difference, but I think networking just teaches you a lot. Like it can teach you more about the career that you want to go into. Like you might teach you more about the industry. There's sometimes you never know what you're gonna get out of it. So I think it's a worthwhile investment for you.